with the recent discovery of objects found to come into our solar system from outside the solar system, so interstellar objects, I want to have a look at the possibility of those objects then hitting Earth and whether they're regular, not regular, and any implications that might have going forward. So it's fairly well known that objects are known to impact Earth. We see them all the time in the skies. You have smaller meteors, and we know that we've had much larger impacts in the past, and we're likely to get them going forward. So we know that impacts occur on Earth from objects all the time. So smaller meteors, like this particular one, are going to be around centimeter to meter sort of size. Meter size, you're likely going to get some damage done, a bit like the one we had a few years ago that broke a load of windows from the shockwave. And then you have much larger ones, which are up to like kilometre sort of size. And these are going to cause significant damage. Now, it's worth noting that the craters I've shown you here, specifically the one on the left, isn't caused by a kilometre size object. It would have been significantly larger, and that's more tens of metres instead. But the point is, as you get larger, they do a lot more damage. So we know that centimetre to kilometre size objects do hit Earth. So the thing that's worth noting or thinking about at the moment or in the past is that we always assumed that these would originate from inside the solar system. So you've got the planets orbiting the sun, and then you have much smaller objects like asteroids, comets, they're all orbiting the sun as well. And it's assumed, or has been assumed, that it's those smaller objects that are crossing the path of the planets, and then they collide with them and you get an impact. So it's always assumed they originate from inside the solar system. Now, there's a few populations that they can come from. The first one is near-Earth objects or near-Earth asteroids. These are objects that are orbiting in and around Earth's orbit. They're moving in a common direction, so you can see lots of these objects here all moving in the same sort of direction. Because they're doing that, their relative velocity to the Earth is relatively small. I say small, they're still obviously hit with quite a lot of energy, but in comparison to other objects, their velocity is relatively low. You then have objects that may have come from further out in the solar system, so towards the Oort cloud, which is the very outer part of our solar system. This is where you would have long period comets. They can be destabilized from external interaction, so maybe a star moving past our solar system can knock it out of orbit. You then have these comets then moving into the inner part of the system, and as they do so, they can collide with some of the planets. And when they do so, they're traveling much faster than a near Earth object, so your collision velocity is going to be higher. So few populations from the outer parts to the inner parts, that's where they're mostly assumed to come from. However, in 2017 and 2019, there was two known interstellar objects, and they passed through our solar system. So these were observed, and they passed through. They were on unbound hyperbolic orbits, so they kind of went almost into one of them went in the inner solar system, one of them a little bit further out from our orbit, but they both passed through the solar system and then back out again. They travelled in very fast and then they left. So in the last few years, we've found interstellar objects that are passing through the solar system. Now, both were travelling far too fast to be captured. If they were travelling slower and they had a slightly different trajectory, then the sun could gravitationally capture them, and they would then be new asteroids or comets in our solar system. I mean, how will we actually know if they were from interstellar origin or not once they're on a bound orbit? It's very hard to actually look into. And also, they didn't impact any planet. So there was no planets in the way of them. They moved through and just straight out. So that's okay. However, 2014, this was actually a few years before those two were discovered, a interstellar object did collide with Earth. Now, it wasn't actually known to be an interstellar object until quite recently. It was after those two were first found. But we know going back that it occurred in 2014 by looking at the records. So actually, this was the first interstellar object discovered or known about. We just didn't realise it until much later on. Now, this burnt up in the atmosphere. It was basically a meteor. And unlike the other two interstellar objects, Earth got in its way. So it collided with Earth as opposed to coming in, but it was on a similar sort of orbit. It was quite a fast orbit, it was unbound, and it was travelling on a hyperbolic orbit. So it would have burnt up in the atmosphere, and the remains of that, what survived, are now at the bottom of the Pacific Ocean. Now, this is actually where the location of that meteor was. This is where it's been determined where it actually fell. And it's just off the coast of Papua New Guinea. And the Galileo project has ideas about going to try and recover fragments of that. And that's quite significant because if you can recover this, it's a known interstellar object. So it's come from outside the solar system. If we can get our hands on that, we can actually start to have a look at how that might have formed around a different star. Because everything we have at the moment, it's all formed in the solar system. So having something that's come from outside the solar system is quite significant. Now, the Galileo project, if you haven't heard about it before, a quick quote from their project goal, basically. So the goal of the Galileo project is to bring the search for extraterrestrial technological signatures of extraterrestrial technological civilizations from accidental or anecdotal observations and legends to mainstream of transparent, validated, and systematic scientific research. So they're basically looking for physical evidence of extraterrestrial technology, really. And there's been some suggestion that this particular object is some extraterrestrial technology. Even if it's not, and it's interstellar object like an asteroid, it still has significant implications. So regardless of what its actual origins are, I think recovering it and learning more about it is going to be very interesting. Now, the actual object itself was just under half a meter in size, and it was traveling about 60 kilometers per second. Now, I've used an asteroid here as an example. That's not an image of the real one. So half a meter in size, traveling quite fast at 60 kilometers per second. This isn't kind of known from the data that was acquired of it. Now, again, like the other two interstellar objects, it was on an unbound hyperbolic orbit, so it would have come in and got relatively close to the sun. However, this time the Earth just got in its way and it collided with the Earth, so it wasn't able to then come out and leave the system like the other two objects did. Now, the interesting thing here is impact velocities, or the sort of velocities that they're going to collide with other objects. Now, a near-Earth object is going to have a relatively low impact velocity of about 15 kilometers per second, and that sounds a lot, and it is, but the other objects are much faster. So a long period comet that may have originated from the Oort cloud, for it to come into the inner solar system, it's going to cross the planet's path, or the Earth's orbital path, at a completely different angle, almost perpendicular. So when it hits it, it's going to be traveling a lot faster relative to the Earth. So around about 50 kilometers per second it may impact for a long period comet. And then you've got interstellar objects. So these are going to be 60 kilometers plus, and these can be over 100 kilometers per second impact velocities. And the higher the velocity, the more, or the greater the sort of damage that it's going to do. The point being, a higher impact velocity of one of these objects will create a higher impact melt in the crater. It means your crater is going to look different. Now, I've given you some craters here on the moon. I'm not suggesting that the differences between these two is because of impact velocity, but the point is they're going to look different. This is just an example, really. So a higher impact velocity crater is going to look different than one that's of a lower impact. Now, we can then basically go to the moon or have a look in more detail at the moon, because we've got a much better record there because they're not eroded away like they are on the Earth. And we can look for interstellar impact craters because they're going to look different. We can look at the impact velocity and determine if they're interstellar in origin or not, because if it originates from inside the solar system, it's going to have an upper limit on how fast it can actually impact another object. But if it's traveling from outside the solar system, they can potentially be traveling much, much faster. So we might be able to identify some of these on the moon as being impacted by interstellar objects already, a bit like we've already seen with the Earth. Now, this is where it gets kind of interesting. In the last few years, we've discovered 3 objects that have come from outside the solar system, and one of those has actually hit Earth. So it suggests that they're not as rare as first thought. So if we've found 3 already, that means that in the past, it would have been a fairly regular occurrence for these to come in, and it's likely that they have and will continue to pass into our solar system. And relating to one of the more interesting questions about how life got on Earth, if we have been impacted by interstellar objects in the past, and fairly frequently, that's going to raise some serious questions or interesting questions on how life originated on Earth. If it related to objects outside the solar system or inside. So, thank you for watching, and if you enjoy, then check out some of the other videos.